Hello there my fried friends, welcome to this video, and in this video I am going to teach you how to build the lid for this battery case which we built in our previous episode. So today we will learn how to build this lid so that we can put this and also we will have this DC jack as well. So we'll make the hole for this, we'll make the hole for the wires and if you have not seen the previous video, I'll link it in the description. Go ahead and watch that. And you will also need the FreeCAD file. You can just get it from the GitHub, which I have linked below. Now let me share the screen, and here you will see I already have this set up. And I'm using FreeCAD version 1.1.1. All right, 3 ones, that's it. Now let's get started. What we need to do is we need to create another body because we are using, we cannot use the same body, okay, and var set will be reused everywhere. So to click new body, make sure you are in part design and click on this new body icon. All right, now we get another body, so another body, and now we'll make this name this lid. Press F2 or double click to rename. No, right click, you'll have to then go and rename this, which the setting is F2. All right, now I'll hide this body. We'll still be reusing the variable from the var set variable set. Now first what we need to do is we need to make the base, okay. So the base will be like, let's do that, and base will go over all the outer surfaces, so it will cover it up, okay. Now we need to make another sketch. Click on new sketch icon, and we'll be making this in XY only. So click on that, and what we also want to do is make a rounded rectangle because we have a rounded case, okay. Now let's get our rounded rectangle here. Click on this and click on rounded rectangle. Click it, drag it, and put whatever you want, and for this just put 2. We'll be changing all this using the variable set. So we have this variable set here, and we have all these values which you can see. So let's first change this R2 because we don't have that much rounding going on. So if you double click on it and you press equals to or function, you can assign the variable set here, var set dot fillet, okay. It is 2 only. Now we need to define the length. So if you look at the var set, we have inner length, okay, and inner width. So this is inner length and inner width, and we need to double the wall thickness this side and this side. Other both right and left side will be calculating. So take this dot, the most dot which is towards the dot which is very towards the left and towards the right. All right, you select those and you can press KD. Okay, now we have to define this. Press equals to will get the editor variable expression editor, and var set dot this is the length, so inner length plus 2 multiplied by the var set dot wall thickness, okay. So this is our length. I'll press OK again. All right, right now it's not fully constrained, so you can move this box anywhere you want. And let's do the same for length breadth, okay. Again get the top and the bottom dot and sorry, click on it, it will turn blue, click on it and press KD. It will constrain. You can also go here and click on this icon on the top dimensions. Press OK again, and we will have to do the same thing. Var set dot inner width into sorry, plus into 2 into varset dot wall thickness. All right. Now this should perfectly fit on top of our box. No hanging edges or anything. It should just be flushed. And I'll show you how it looks after printing and all. Now to center this up, we can simply just select this dot. The order is important here. This dot and the dot in the center. And now we need to use this symmetry constraint. Just click on it. Sorry, it did not work. Let's try that again. 1, 2, and the center. Make sure you are selecting the dot, not the line. Yeah, there we go. Now it says fully constrained here, right here. Now I'll close the sketch since it's fully constrained. Now what we need to do is pad it. All right, now we will have the base of the lid. To how much do we want the pad to be? Click on this function and lid base height and store it in, sorry, this is the name. We'll store this in variable as well, and let's see how thick that we want it to be. I think 2 mm would be more than enough. So we are having 0.4 mm layer height, so 0.4 divided by, sorry, multiplied by 5. So we will have 5 layers slapped onto each other like a sandwich to get that height. Okay, 20 mm. Sorry, it's 2 mm, not 20 mm. Okay, I should have multiplied. Yeah, this is 2 only. 0.4 into 5. Yeah, perfect. Oops. I pressed escape, so let me do this again. And now we press OK. Alright, this is the lid. Now to show you the visual, what we can do is if I enable body, you see it perfectly fits. Okay, there is nothing coming out, extending out. Everything is just flushed, totally flushed. Let's hide the body now. And now what we need to do is we need to make the inner border. And we'll also need to make the holes. All right, to make the holes, it's pretty easy. We go in the same sketch. Now for this DC jack, you need to measure how wide this is. I'll do that quickly with my vernier caliper, and it seems it is around 12 mm. Okay, let's get a circle, and I said it was 12 mm, so I'll type 12, and now we can store this in variable set as well. Click on FX, store in variable set, and you can name it DC jack hole diam. Just make sure you are getting the diameter, not the radius. If you measure it cross sectionally like this will be the diameter only. So try to get diameters. That works best. Now we need to decide where we want this to be. So let's put it in the corner here for now. And we also want holes from our wires. So I'll measure the wire thickness, how much do they need to be, and I'll make like a slotted circle this time. So my wire outer diameter is around 2.8 mm. So and 3 mm. So let's think of it outer diam as 6 mm. Okay, what do? We get this slotted slot. Click here and make it like this. Okay, it's not constrained yet. But also what we got from the wire was the thickness. So it was 3 mm. So I'll make this and this KD 3 mm. Okay. We don't need to store this in variable. If you want, you can do that, but for me this is fine. And here also we got the entire diameter from the two circle in a so you can do is add a point here, add a point here, get the dot from here. Okay, point G and Y. Now what we do is click on this and press V so that it becomes, sorry, press H so that it becomes horizontal. Okay, I pressed H. Now I can't move this, but this one still moves. So we do the same. Take this and this. You don't want to press H, you can go somewhere in here and yeah, horizontal vertical constraint. I'll press H again. Alright, and this is fixed, but this is still moves. So we take the outermost dot from both the sides and press KD. Okay, and we know how much both our wires was. It was 6 mm combined. So there we go. This slot is done, but we can still move this. So I'll keep this in the corner right now. Okay, later I'll show you how to fix this. Okay, click on close. There we go. This is the hole we have for the wire, and this is the hole we have for the DC jack. Now let's make the inner wall. That is going to be pretty simple too. Click on new sketch, and we want it to be on XY as well. I will hide this since we don't need it, and again come back and use the rounded rectangle. 2 mm, this will be replaced. Double click, varset, fillet. Now we need to put the length. Again, go to the right dot, left dot, and press KD again, equals to, and this time we do not need to add the borders because this is going inside. So this is minus, like without the wall thickness, this is the internal, wall. Varset inner length. Okay, and now we do same for this side, vertical side, KD, and equals to varset inner width. Alright, we have already learned how to center this up. Select this dot, the corner dot, and again in the second you select the corner dot again, and in the last step you select the middle center dot, and you press the symmetry, and now it's fully constrained and it is in center. Okay, but this is just another pad. What we want is just we don't want to waste a lot of filament. I'll show you how this will come up. If you want this kind of style, you can do that as well. I'll lid wall height, I'll make it also how big you want this to be will also depend on how much cavity you have in here. Let me just measure it, and I'll also account for the wire. I have 8.7 mm, so I can make this 8.8. okay, and I will store this in a variable set in case you want to change this. 8.8, it will be let's call it a lid wall height. Hit OK, hit OK as well. So right now you see what happened. Our hole got blocked as well, and You could make it like this as well, the entire solid fill, but I don't like it like that because we have lot of space here which can be used, and I'll have trouble installing the DC jack. So let's go back here and create internal wall. Usually what we were doing is we were adding the wall thickness, but this time we will be subtracting the wall thickness. Again, start with the radius first. Now let's assign the height, length. This left dot, right dot, okay? KD, that's it, equals to var set. This time, as I said, inner length minus, because we want some wall thickness, however thick you want the wall to be, you will say that, but I want it to be same as the battery wall thickness. So what I'll do is var set dot wall thickness multiplied by 2. Okay, uh, there we go, we have fixed that. Now let's fix the width or breadth. I select the outer topmost dot, bottommost dot, and I press KD. Okay, and same thing we do here. Var set inner width minus 2 times var set wall thickness. All right, again let's do it this in make this in center, the corner dot and the bottom corner dot, and at last the dot in the center. And there we go, we have it fully constrained. And if you have trouble selecting this, what you can do is you can hide constraints by clicking on this icon, and you can just select the dot. Alright, guys, this is done. I'll close this and show you how this looks. Okay, you see, this is the problem we got here. This is in corner and it overlapped with the wall. So let's fix that. Go back to our base sketch. This was our initial sketch. What we can do is we can fix this here. I can select these two dots, and either I can just add. So the best would be to account for the wall thickness and add some margin to it. Okay, KD, sorry, this is we can't do KD here. What we can do is the length. Okay, so if I press I'll get vertical, and if I press L, I'll get horizontal. So I pressed L, and how much do we want this to be away from the wall? We want it to be a bit further than the wall, equals to var set wall thickness plus, let's say I want to add a 5 mm of gap. Okay, and we can put a reference here. So for example, I can name this edge dist, and we can reuse the same variable on here as well. 2 dots, and I press I this time because we want the vertical, equals to, and we type constraints because this is in the same sketch, constraints dot edge distance. Okay, this is how it is looking now. This one we have got perfect. If I close this, you will see it's at a distance now, equal distance, because we added 5 mm gap. Now let's fix the hole, and in the hole you also have to account that there is some outer bolt here which needs to be rotated to install it properly. Let's go to the basic sketch, and I think additionally, how thick is that going to be? Yeah, it's around 3.2 mm. And to the thing is, this is circle, so how do you put a distance from the edge? You again get a dot, add this dot here, okay, and this dot will be moving, so I can press H to get it horizontally here, and now we can put the distance from the edge. I'll press L equals to, and constraints. I'll just use the same edge distance because I have enough clearance to rotate, or let's add a bit more, or we'll see about that. Okay, now this is done, but this still moves. So let's add another dot here so that we can give distance here, and I'll do this and this, and I'll press V. So now this is vertical, and this bottom dot, this bottom dot, and the bottom dot, and I want vertical distance, so I'll press I equals to constraints dot edge distance, same thing. Now I close this. So there we go, we have this hole for our DC jack, and this is the lid. So we are done with this, and yeah, that's it. And I'll show you how this goes, and after printing, if you want how to print this, go check out the previous video. And once I print this, I'll show you how I install it. And one more thing you can do to make your life easier is just add a bit of tapering. What, like right now it's this, but if you taper, it will tilt like this, and you can easily push it down. Taper this, go to this pad where we made the wall, and here you see on the right there is taper angle, and you can just make it 1 degree. So if I am doing this, it's, you see, I'll show you like this. Yeah, it has bent like this. Show preview overlay, I'll just show you the final result. So you see, this is how it's curving. We don't want this much, we just want minus 0.5 degree. Okay, just a bit of clearance. If you do too much, it will be really loose. Okay, I'll press OK. You'll have to tweak this based on your filament and all. I'm using PLA, and yeah, this is done for the FreeCAD tutorial. You can save this and export. To export the lid, you'll click on lid and go to file, export, or just press Ctrl E, and you can select AMF, 3MF, or STL, whatever you like, and you click on save. Alright, so this is our battery pack, and we have got the lid printed. This wall could have been a bit longer here so that it has more grip when we insert it. And this is our DC jack. You can see it has threads, and we have the hole here. So let's do this one first, and I'll just push this, and here, from here, I'll put the nut. Just grab it, and you can rotate it with your hand till you can. Once you have totally tightened this, what you need to do is grab a flathead screwdriver and try to rotate this. Also make sure you are holding this part. Use the support from walls and just try to push it. So now it does not wiggle, and we can just plug it in. Now what you will have to do is solder these two wires on back of the DC jack, and from this hole we are going to take these two wires out. If it's this hole is too thin, what you can do is make it bit bigger. Alright, so depending on your need, but yeah, I'm just going to solder this and put a battery connector on this after soldering this, and yeah, this will be done. Okay, uh, I'll show you once I have completed this. Turns out the hole we printed for the wire became bit small, so I just took my screwdriver and used the Phillips head to make the hole bit bigger. Just make sure while printing, before print, that you have made this hole big enough that both of your wire can pass and you don't end up doing the same like me. Here I got XT60 connector which can handle 60 amps. I did not need that much, but I wanted the bigger footprint so that I can easily hold them and plug them with my hands. And here I am inserting the heat shrink tubes. Now all I had to do was just solder them, and then yeah, there we go, we can heat it up and just shrink the heat shrink tube. And also the another thing with these connector is you cannot install them in a reverse order, so polarity will always be correct. And yeah, there we go. I hope you enjoyed this video and learned something new. If you did, make sure to like and subscribe.